Okay, section 1.5, we are just going to be analyzing your graphs of your functions, so just different things about our functions. So this first one, find the domain and range. So remember, domain is our left and right. So if we're looking domain, we'd be looking from here to here. Domain is left to right. So the domain of this function would be from -1 to 5. -1 is in brackets, 5 is in parentheses, or you could say x is less than 5, greater than or equal to -1. Interval notation, inequality notation. Okay, so domain is looking left to right, and then range is looking from the lowest point to the highest point. So lowest point is right here, highest point looks like it's right here. No breaks in between, so we don't really have to worry about that. So range is going to be from -3 up to a +3. Or you could say y is less than or equal to 3 and greater than or equal to -3. The other thing that you need to be careful on when you're looking at your graphs, just because of the way it's drawn in pictures and stuff, students sometimes think, well, if I don't see this big old point right here, then it must be an open circle. No, these are all closed circles. Just because you don't see the point doesn't mean it's not a closed circle. Default is closed circle. Everything's a closed circle unless you specifically see it drawn as an open circle. Okay, so that's default. That's how it always works. Everything's closed. Doesn't matter whether you see a big solid point or not, unless you see it drawn open. Okay, find the function value. So remember, this is your input right here. That's your x value. So I'm going to come over here to -1 and then go up, and you can see that you get 1 out. That's your point. They've got it drawn right here, -1, 1. F of 2, so same thing. I'm going to come over here with 2. I'm going to come down to this point, and that turns out to be -3. So it's the point right here, 2, -3. And then f of 4, so I'm going to come over here where x is 4, right here. And the y value there is 0, so that's going to be, that would be the point for 0. Okay. All right, this one says use the vertical line test to decide whether the graphs represent y as a function of x. Just using that wording, y as a function of x, we're just trying to decide if it's a function, meaning x is your input, y is your output. That's what we're used to. It's just different phrasing. So this one is no, does not pass the vertical line test. So that's a no. This one is a yes. Right there where it looks like it could overlap, there's an asymptote right there. So this one is a yes, this one's a function. Here, I do have things stacking, but that's closed and open. So since there's no repeat, that would work, that point would work, and that point would work. So this is a yes also. A parabola, yes, that's a function. This is a cubed root, so yes, that's a function. And then I have these random points. I tried to line these up, so hopefully that looks vertical to you. So this would be a no, not a function. Doesn't pass the vertical line test. Okay, so the zeros of a function are the x values for which f of x equals 0. So that means your y value is 0. You're looking if they cross the x-intercept is what you're looking for. Or sometimes you can solve that and it's not an x-intercept, but it's also called a 0. So zeros, you're going to put it equal to 0 and you're going to solve for x. All right, so hopefully you remember this is quadratic. So if it's quadratic, the first thing I think of is, can I factor it? If I can factor it, I do that. If I can't factor it, then I go to quadratic formula to solve it. So I'm thinking factor pairs of 3, 1 and 3. Factor pairs of 10, I'm going to do 2 and 5. So I'm going to put the 2 here, 5 here, plus here, minus here. Okay, I'm going to do a quick check. That's a -5x. That's a plus 6x. Add them together, and I get positive 1x is which I wanted in the middle. So there we go. I factored it correctly. Then I'm going to take each parenthesis and I'm going to set it equal to 0 and solve it for x. That's going to give me my two zeros. So 3x minus 5 equals 0, and x plus 2 equals 0. So my answer is, some of you are probably doing this mentally. You probably could just look at the parenthesis and get the answer, and that's great. So x equals 5/3 or -2. All right, this one is a square root function. So if I'm going to solve the square root function, first thing I have to do is get rid of the square root symbol. So I'm going to use the technique of squaring both sides. So when I square both sides, 0 squared is still 0, equals 10 minus x squared. Okay, then I'm going to add 10, I think I'll add the x squared to the other side. So x squared equals 10. Take the square root of both sides. So x equals plus or minus the square root of 10. So that's our values there. We got plus or minus the square root of 10. Okay. Find the zeros of each function graphically and verify algebraically. Okay, this one looks a little tough to do algebraically, but we'll see if we can figure out the algebra and then we'll go to the graphing. So here we go, x to the third minus 4x squared minus 9x plus 36. Okay, it's a cubic. And the only thing I really know how to do, guys, is factoring and quadratic formula. You did a little bit of the synthetic division last year, but mostly right now our toolbox is we either got to factor it or put in the quadratic formula. It's an x to the third, so it can't go in the quadratic formula, so it has to factor. Okay, so how am I going to factor that? Let's try grouping. Let's group the first two and the last two and see what happens. So out of the first two, I'll take out an x squared. That will leave me with x minus 4. And out of the last two, I'll take out a -9, and that will leave me with x minus 4. If it's going to factor by grouping, those parentheses should be the same, and they were. That's now your new GCF, so I'm going to bring that out, x minus 4, and then I have x squared minus 9. Well, x squared minus 9, as long as that power is not linear, you got to think, can I keep factoring? Yes. So x minus 4 goes to x plus 3 and x minus 3. Okay, here we go. So what are our zeros? X equals 4, -3, and +3. So not too bad. Okay, let's do that algebraically. So we did that one algebraically, so let's do that graphically and see what that looks like. So let's pull this up on our graphing calculator, and we're just going to type into our y equals, we're going to type in x, so use this x right there, raised to the third, so caret 3. Oh, whoops, I don't want that. Oh, I already had something from last time. Okay, sorry, I didn't look. I should have cleared that out. Let's clear this whole thing out first. So clear that one and clear that one. Okay, now let's type it in. X raised to the third minus 4x squared minus 9x plus 36. Okay, hit graph. And we're interested in the zeros. We're interested in where y equals 0. So right here, here, and here. And those are the answers we got. So everything is matching. You could also see that in your table. So go second table. Let's go table set and put that back at a 1 so that I can see my table a little bit better. So there we go. There's our 3, 4, and we have one in the negative direction. -3. There's our 3 zeros right there. We can see them in the table as well as on the graph. Okay. Now let's do this other one. So 2t minus 3 over t plus 5. You may not know what the graph of that looks like. We'll graph it. And how do we do that algebraically? Well, algebraically, we set it equal to 0. 2t minus 3 over t plus 5. Okay, so I've got to get rid of what's in the denominator. So I'm going to multiply both sides by the t plus 5. So that reduces that part of the fraction, and 0 times t plus 5 is still going to be 0. Nice. That totally got rid of the fraction. So now we don't even have to work with a fraction. So add 3, and then t equals, oops, other way around, 3 over 2. Okay, let's graph that and see if that really is our 0. So back to our graphing calculator. So back to y equals, let's clear that one out and let's type in. So if you're going to do this left to right, you have to do numerator and denominator in parentheses. So if I go left to right, I would go, and we don't type in a t, you just do everything for x on your calculator. So 2x subtract 3 divide, and then the whole denominator needs to be in parentheses, x plus 5. Okay, and then you can hit graph, and it will show you the graph. And where was it crossing at? It's kind of hard to tell on your graph that it's right there. So this might be one. Let's see what we have in our table. And notice in our table, I don't see the 0, but this is what happens. Right here, where it changes sign, see how that went from a negative to a positive? That means there's a 0 in there somewhere, in between 1 and 2. Now, if you wanted to get more exact to a decimal, go back to your table set and see how this delta table is set at 1. If you change that to a 0.1, it will give you decimals. So I'm going to change that down here to a 0.1. And now let's go back to our table. And let's see if we can figure out where we got our 0. So let's scroll that up. Scroll it down. Let's see. We want it to be at. I should have just done where I thought it was at. Didn't I say 1? Let's just do table set. And didn't we think it was at 1.5? And there it is, 1.5. You can see the 0. So I don't usually have the decimal just because there's so many choices in the table if you have it set as a decimal. But it's nice if you want to go verify decimal. So I'm going to set it back. So second, I'm going to go back to table set, and I'm going to set my calculator back at 1, not 0.1, because I don't want to see decimals. And oh, I wonder if I left it at 1, if I would have done that as a fraction, if that would have worked. Or, I mean, if I did 1.5. Let's see what that looks like. Just curious. Oh, that might be left over from last time. Now I don't know if that would have worked. Let's go back to 1. Maybe if you type in the decimal. I'm going to check that here. So see how, there we go. We can't see it. Now I'm going to go back to table set. And I'm going to start it at 1.5 because that's the one I want to check. Okay. Oh, yeah, you didn't even have to change that delta to 0.1. Nice. Okay, I learned something new. All right, so I'm going to go back to table set, though, because I don't want all those decimals. I'm going to change that one back to a 1 also. Okay, and so there's our table. And here's our graph. We can see that where it crossed, so everything was matching graphically and algebraically. All right. Functions can increase, decrease, or remain constant. Check graphically what is happening as you move left to right. So we always describe what our graph is doing as we move left to right. That has to be the same, because if some people were going right to left, you would get a different answer. So we always check moving left to right. So if you take this one, notice if I start from the left, even though there's kind of a curve to it, I'm still increasing. As I move left, and I move to the right, so I start on the left, and as I move to the right, it gets taller and taller. It's increasing. This one, as I start on the left and I move right, the whole thing is decreasing. This one is just remaining the same, left to right, constant. Nothing's changing there. And then on this one, this is decreasing, then it's staying constant, and then it's increasing. Okay, so that one had all 3 of them in it. All right. So increasing and decreasing functions. So when we're talking about increasing and decreasing, now there's a little bit of discrepancy here. On do you have to keep track of parentheses and brackets when you're describing the interval, or can you just do them in parentheses? All right, well, last year's textbook kept track of parentheses and brackets. This year's textbook just says you just have to do the domain. I personally just keep track just because we're so used to it. I wouldn't mark it wrong. The one thing that you have to make sure that you understand, though, is that this is not a point. Negative 2, 0 is not a point. It's just decreasing from negative 2 to 0. It's staying constant from 0 to 2. And then from 2 right here to 4, it's increasing. So those are interval, that's interval notation. So what I'm saying is that there's a discrepancy, like my textbook last year, the pre-calc book would have taken this graph and decreasing, they would have put it as a close point here on the negative 2. So they would have said negative 2 and then 0. And they would have put either bracket or parenthesis. And then on the next one, since it picked up and this one was closed, it would just say 0 to 2. And then this one would have said 2 to 4, like that. That's how it would have written it last year. So I'm not going to be super picky on that. If you're like, oh, is it supposed to be parenthesis or bracket? In the book, this book uses the word open interval, that wording. So I feel like that wording kind of takes away the discrepancy. So since they're using the word open interval, they want you to use only the open symbol in interval notation. They want you to use parentheses, not brackets. But like I said, I'm not going to mark it wrong if you do both. So this particular one right here, it says determine the open interval on which each function is increasing or decreasing or constant. So this one right here, you can't really see it, but it's kind of one of those things that understood that there's arrows on each end. So this one is actually increasing the whole time. So we are increasing from negative infinity to positive infinity. There is no, like, we're not cutting it off right here to here on the domain. This graph actually goes, is continuous in each direction. It's just because they give you the formula x to the third, so I know that. So this one right here, they give us the formula x to the third minus 3x. So same thing, even though you don't see the arrows, we know that it's continuous and it's going in that direction forever. So if we're going to talk about the word, so it looks like to me we're increasing in this graph, then we decrease, and then we increase again. So that's kind of the pattern that happens. Well, you don't write the word increase 2 times. You just only write increase and decrease, and you just put the symbols on what it matches with. So first of all, I'm starting here, and I'm increasing. Okay, first thing you're going to want to do to just so that you don't get messed up with, am I doing what value I'm doing, because the most common error is to put the range value instead of the domain. I would, where you change directions, let's just put a line right here, change directions. And then I would come over here, circle this, circle this. That's what you have to keep track of. You're going from here to here, then I'm going to here, and then I'm going to here. It doesn't matter how high or how low I go, it's just the left and right that I care about. It's the domain. So we're increasing, first of all, from negative infinity, because we're moving from the left to negative 1. Then we're decreasing, this piece right here in the middle is where we're decreasing, and that's from negative 1 to 1. And then we jump back up to increasing, so I'm going to put that little union symbol, and then I'm going to say that's 1 to infinity. Okay, so if you, that's pretty much how you'll see it in your book, but maybe some of you guys are so used to from last year and you're like, no, I got to put a parenthesis. If you wrote it like this, I wouldn't mark it wrong. If you did increase and you said negative infinity to negative 1 and you did a bracket and then you did a bracket 1 to infinity, that would be all right. Just don't put brackets on infinity symbols. That would not be okay. All right, so you could have done brackets and I would have marked it wrong, but your textbook doesn't do that, just so you know. Okay, over here we've got, it looks like increasing, constant, decrease. So it looks like we've got all three. Looks like we're increasing first, and then we're going constant, and then we're decreasing. So once again, I want to keep track of left to right. So I am going to, anywhere I have a change of direction, I am going to do this, and then I'm going to be like, okay, I need to keep track of that and that. So I'm going left to here, like that. So that's my answer. Everything that's highlighted in yellow. I don't care how tall, I don't care how low it goes. It's only the yellow path that I care about. So if we're increasing, we're going from negative infinity to 0. Then we're staying constant from 0 to 2. And then we are decreasing from 2 to infinity. So I just read this yellow right here. That's all I read. I don't care how high, how low it goes. I only care about the yellow. That's how we do our notation for increase and decrease. Okay, the points at which a function changes its increasing and decreasing or constant behavior are helpful to determining the relative minimum or maximum of points. So you can have, a graph can have more than one min or one max. So these right here are labeled. This is a max and this is a max. They call them relative max. If you want to know what the absolute max is, the absolute max would be the highest of the two. So this one would also be called absolute max. And you could do the same thing for mins. So we could say, here's a min and here's a min. Those are both mins. What's the absolute min? This one right here. It's the lowest. But if you just want to say the max or the mins, we just talk about all of them. Okay, so this one says find the relative minima or maxima of each function. So they want you to find all the max or mins is basically what it's saying. So hopefully on the one on the left, you recognize that one as a parabola. And so we know how to find the vertex of a parabola. You may have forgotten, I don't know. We'll do a quick review of this one. So since this one's in standard form, in my classroom, I have that on the wall, and right underneath it, I have the axis of symmetry. So I don't know if you guys remember, but if I'm in standard form, I can find the axis of symmetry with this formula, opposite of b over 2 times a. So my axis of symmetry is going to be 4 divided by 2 times a. So it's going to be 4 over 6, and reduce that, so 2/3. So remember, if you're drawing a parabola, and here's your axis of symmetry, that's your vertex or your min. That's also the x value of your vertex. So my vertex, and I know this one is a min because the 3 is positive, so I know it's opening up. So my vertex is going to be 2/3, comma, something. Well, how do you find the y value? You take your x and you substitute it back into the original problem. So I would just go ahead and type that in and see what you get. So that's a negative 3 1/3. So there's our vertex. So that would be the min right there. That would be our minimum value. So this one also says you can do it on a calculator. So if we were going to do it on our calculator, let's pull that in. I would go to y equals, clear that out, and we'll type in our equation. So it was 3x squared minus 4x minus 2, and then hit graph. And then how do you figure out what this point is right here? I mean, that's great, but I still don't have the value. I mean, I found it algebraically, so I know what it is. You can do back to calculate, so go to second, and then the calculate button, and then look, what am I looking for? I'm looking for a min, so let's just hit 3. And now let's follow the prompts. The first prompt says left bound. So that means you need to be on the left-hand side of your vertex somewhere. And I am, so I'll just hit enter. And now the prompt changed right here. It changed. It changed to right bound. So you need to be on the right-hand side over here somewhere. So you can either right arrow, so you can right arrow, or you could type in a number that's to the right of it. So I could just type in 2 and hit enter, and it'll move me there. So now I have a right bound. And then my last prompt says make a guess. So here's your last prompt. Guess what you think this point is right here. Where do you think that x value is? Well, I think it's 1. So once again, you can move your arrow, left arrow, see how it's getting me closer, or I could just type in the number 1. I think it's at 1 and hit enter. And so what is it? It's 0.6666. Well, that's 2/3. And then a negative 3.3333, that's negative 3 1/3. So there we go. We did that. Here it is right here. I'll graph out what we did. Okay, so we could do that one algebraically, did it on the calculator. This one, we will learn how to do this algebraically to graph by hand, but right now, no. So this one, we're just going to start right with the calculator. So we're going to go to the calculator and type in y equals, and let's clear that out and type in x to the third minus 3x squared minus x plus 1. Okay, hit graph. All right, so we need to find out what these points are right here. We've got a max right here and a min. You can find either one that you want first. So we're going to go back to calc. And I guess I'll do the max first, so number 4. So we got to be left bound, follow your prompt, right bound, and then guess. And there we go. So there's our max. Our max, I'll put it on our next screen here in a minute. I'll write it on my board for a minute. So our max is negative 0.154, comma 1.079. We'll just go to 3 places. Okay, and now let's do the min. So back to calc, second calc, let's do the min. Follow our prompts. We need to be on the left-hand side. So there we go. I'm on the left. Enter. Right-hand side. Enter. Make a guess. Enter. So the min is 2.154 and then negative 5.079. Okay. So here's a picture of what we just did. And here is the max was negative 0.154, comma 1.079, and the min was 2.154, comma negative 5.079. Okay. So learning how to use some of those buttons on your calculator. This one says graph the function and determine the intervals for which f of x is greater than 0. So we want to know where it's increasing. Greater than 0 or equal to 0. We want to know where it's increasing. We want to know that interval. Now, since it wants an interval, not open interval, you're going to need to keep track of parenthesis and bracket if you need to. So this one, I don't need a calculator to graph this one. I know this one's a square root. And its starting point is 3, negative 1. So 1, 2, 3, negative 1, and it goes like this. So where is it greater than or equal to 0? So what we need to do is figure out right here is where it crosses 0. So we need to have from here over. That's what we're looking for of that graph. So I need to figure out what that number is. Okay, since I made a sketch, I don't really know. I mean, it looks like it's more than 3. I don't know what it is, 3.2, 3.3, I don't know. So I am going to put this equal to 0 and do this algebraically. That will tell me where it's equal to 0, right? Because isn't that where my y value is 0? That's what happens when we're trying to find greater than or equal to 0. So square root of x minus 3 minus 1, add the 1. To get rid of my square root symbol, I am going to square both sides. And now I have 1 equals x minus 3, and then add 3, so I get x equals 4. Oh yeah, I didn't graph that very accurately at all. So if you were a little bit better with your graphing, you would have seen that that was, if we would have graphed it exact, we would have went up 1, over 1, we would have known. I just made a poor sketch, so I couldn't tell. So we want, so I could check it algebraically. So we want to know that interval. So where is it greater than or equal to 0? Well, it's from 4 to infinity. And notice I had to put a bracket because this said equal to 0. All right, so same thing on this one. This one's a parabola. So something like, oh, I think it goes through the origin. So I'm just trying to make a quick sketch here. I think it looks something like this. Okay, and how did I know that? Well, I was looking at it as factoring it. So if I put this equal to 0 and I've got to solve it, it's quadratic. So I always think factor or quadratic formula, factor. So if I'm going to factor it, it looks like I can only do a GCF. So then that means x equals 0 and x equals 4. So right here is 0, and this point right here is 4. Okay, so what we're interested in, where is it greater than or equal to 0? Well, where is it above the x-axis? Right here and right here. So what's our interval? It's from negative infinity to 0 or 4 to positive infinity, because it's all of this stuff right here, this interval right here, matches with all of this. We want stuff left to right. Even though that's above, we want the stuff that goes left to right. So I had graphs here that you could look at. So greater than or equal to 0 is this part of the graph right here and this part of the graph right here. But what you're interested in is the x's that go with it. So you need all these x's, all of these x's, all of these x's that go with that part of the graph. You're interested in this. Just like over here on this one, over here, it's graphed exactly. We were interested in from here over this right here. You got to have all that x's from here to here. That's what we needed. Where was it greater than 0? That's what we're looking for. Okay, just trying to make that look a little better. Here to here. That's what we're looking for. All right. So average rate of change is the same thing as slope. So it says find the average rate of change of the given function from x1 to x2 when x1 is 0 and x2 is 3. Okay, so on that picture right there, I've kind of got it dashed. It's like, well, what is the slope between those 2 points? Well, here, this was the 0 right here. This is 0, and this is 3. So if you come up, we're looking for what's the slope between these 2 points right here and here. Well, you could count it out on your graph if you wanted. It looks like I'm going down 2 over 1, down 2 over 1, down 2 over 1. But the nice thing is when it's linear, this is linear. Average rate of change is the slope. You could have just looked at it and said it was -2. So when it's linear, you know what your average rate of change is without even looking at the graph or doing any of the slope formula. This one right here, find the average rate of change when from the function from x1 to x2. So if I have a picture, which I gave you a picture right here, here is this, it's kind of hard to tell where 0, 0 is. Here's 0, 0. So this is -1, and this is +2. So if I come down here, this point right here is -1, -3. And this point right here is 2, -1, 2, 3, 4, 5, 6. Okay, so I could just count it out. It looks like I'm going down 1, 2, 3, and over 1, 2, 3. So counting it, the slope was, I went down 3 to the right 3. So that looks like it's -1. You could do a formula. So I could have said, well, slope formula, -3 subtract -6 over -1 subtract 2. That gives me 3 over -3, which is -1. So that matches. Okay, if you don't have a picture, so this one was nice because I had a picture. What if the picture was gone and all I gave you was f of x equals x to the third minus 3x squared minus x, no picture, and I said the same thing. When x1 is -1 and x2 is 2. Okay, you have no picture, so how are you going to do that? Well, you're going to have to take -1. So you're going to have to take -1 and plug it into that formula and figure out what the y value is. So if I don't give you a picture, you still have to find the points. Okay, so I know that it's supposed to be -3 because I have a picture. Let's type that in and see if we get -3. So this is -1, this is 1, -3, and this is +1. So yeah, so when I put in a -3, or excuse me, a -1, I get a -3 out. That was the point, -1, -3. Perfect. Okay, do the same thing when you have 2. So do f of 2, plug it into the original formula. So 2 to the third minus 3 times 2 squared minus 2. All right, well, this is 8. 2 squared is 4. 4 times -3 is -12 minus 2. So a -14 plus 8 is -6. So did we get the same 2 points? We did. It's 2, -6. And now you can go back to using the slope formula if you needed to, if you had to find the average rate of change. So if you have a picture, it's really nice because you can just count it out on your picture. But if you don't have a picture, you either have to draw the picture and find the points, or you just substitute in the x values to find the y value. All right, odd and even functions. So we've got to determine if these functions are odd and even. So graphically speaking, odd functions are symmetric with the origin, and we talked about that on an earlier lesson. So if you look at your picture and it looks like you can fold it over the y-axis and the x-axis and it folds onto itself, then it's odd. Even functions have symmetry with the y-axis, so you just have to fold it on the y-axis. So this right here, if you were to take this point right here, see if I fold it over the y, it comes over here, and then if I fold it over the x, it comes to here. So it's actually the exact same thing. And then this one, if you fold it on the y, it maps over here onto itself. It has to map onto itself. It has to be symmetric there, okay? All right. Let's see, and then that's graphically. Let's see, the slide above it, the box above it says, if you're going to test if it's even, what happens is if you put in right here, if you put in the opposite, you should get the original function back. So if I put in a -x for the x, I should get the original function back. And if I, over here, if I put in -x and I get opposite of the original function, then it's odd. So how does that work? Let me show you algebraically how that works with these two things, since we have the equations here. Okay, so here's this equation right here. H of x equals x squared plus 1. That's my original. What I'm going to do is I'm going to take my x squared plus 1, and for the x, so see here, for the x, I'm going to put in a negative x. So I'm going to go negative x squared plus 1. Okay, do the algebra. A negative x raised to the second power is x squared plus 1. See how that matches the original. That's even. Okay, now let's do this one over here. So this is g of x equals x to the third minus x. Okay, we're going to put in a negative x right here. Okay, now let's do the algebra. So this is going to be minus x to the third, and then this is going to be plus x. Okay, so if we take a negative sign out of this, so I'm going to factor this, I'm going to show you two different things here. I'm going to factor out a negative 1. So see how this part right here is the original, and then we have a negative sign out in front of it. That's what it's saying. The original, and then a negative sign out in front. It's the opposite. Or you could backtrack, and you could look up just one step back right here. See how all the signs have to be exactly opposite, and they are. So that means it's odd. It's the opposite. Opposite of f of x. So algebraically, you substitute in a negative x, and if you get the same function out, it's even, and if you get the opposite of the original function, it's odd. All right, so we're going to try to decide if these functions are odd, even, or neither. So I've given you the pictures, so we could look at them, and then we will need to do this algebraically to make sure it matches algebraically. The fractions get a little bit tricky to do algebraically. So this one right here looks like right here is the y-axis. I would say this is even. Looks like a symmetry in the y-axis. So if I were going to do this, I would say f of, I'm going to put in a negative x for x. And then I do the math, and a negative x raised to the second power is x squared. And I'm done. Does that match that? Yes. So yeah, we proved algebraically it's even. Okay, over here, here's the y-axis. That is not symmetric with the y-axis, so I think it's either. All right, let's see how that looks algebraically. So g of negative x, so I'm going to put a negative x squared minus 2 times the negative x minus 2. And then we're going to go ahead and algebra on that. That's x squared plus 2x minus 2. Okay, does that look like the original? I don't think so. I'm looking right here. That sign is different than that sign. So that's not even. Is it exactly opposite? No, because these two signs are the same, so that's why it's neither. Okay, now we're going to do the fraction one. So when I look at the fraction one, it looks like to me that this is odd. Here, if I took this branch and I flipped it here, it would go here, and then if I flipped it down, it would flip over onto itself. And then this piece would flip down to here and to here and then flip over to there. So yeah, it looks odd to me. Graphically, it looks odd. Okay, let's see if we can make that match. This one is the hardest one to test algebraically. So if I'm going to test it algebraically, I'm going to put in the negative. So I'm going to go negative to the third, like that. And then I'm going to go minus x squared. Okay, that turns out to be a minus x to the third plus x over 4 minus x. All right, so people look at this one and they say, well, it's neither because it doesn't look the same. Oops, x squared. It doesn't look the same, and it doesn't look opposite either, because see, look, this 4 minus x squared, matches, but the top one doesn't, and it's not opposite. Okay, but remember, you want to make sure it's exactly odd. Okay, we're going to backtrack for a minute. If you had this fraction right here, if I had, let's say, 1/2, and I wanted to know what its opposite is, you'd say it's -1/2. Now, I could write -1/2 with a negative sign out in the middle, or I could write it out at the front, at the top like that, correct? Okay, so what if, I don't know if this is going to help you understand or not, but I hope so. What if I take in the numerator, let's take out a -1. That's going to be negative, that's going to be x to the third minus x over 4 minus x squared. Now, does that look like that's the opposite of h of x? It does to me because look, if I cover up this sign right here, this negative sign, let's fill that in. Oh, I didn't fill it. Well, I want it to be filled. See, if I cover it up, now it looks identical to the original. So this right here, this is the original function, and this is now the opposite when you put the negative sign out in front. So yeah, that one is odd. That one's odd. That one's the hardest one for everybody to see. Graphically, it's a whole lot easier for people to see than algebraically to figure it out. The fraction ones are tricky. Everything else just matches up. It's either the original or its opposite. But the fraction ones you have to think about. You have to take the original function, make sure you find the original function, and is it opposite of that function? Okay, we're done. We made it through.